Hello, this is Dr. Mears, and today we are going to be learning about the derivative function. And I'm really hoping that I do an okay job at explaining this because it is such an important concept, especially when you are being introduced to the world of calculus. So here we go. What we're going to be looking at is a curve, and in particular, just for this one example, we're going to be looking at this curve right here. And when we talk about derivatives and when we talk about the introduction to calculus, I want you to think about rate of change. And rate of change is how some variable changes over another variable. So how your number of miles traveled changes over time. That is a rate of change, the rate of which something is changing. And if we look at this curve, and if we're trying to get the rate of change, we notice that it's not constant. If it was constant, it would be a nice straight line that has a constant rate of change. And when we have curves in calculus and in life, mathematicians and other people want to find a rate of change, and it's really hard to, because in a curve, this rate of change or its steepness is going to be different than this rate of change, which is its steepness. It's harder to do with a curve than a straight line. So what we're going to be using is we're going to be using the derivative. And what the derivative is going to help us to do is it's going to help us bring this point Q closer and closer and closer to point P, that we're actually going to get what's called an instantaneous rate of change. So we're actually going to be capturing part of this graph at this point. At this point, what is the rate of change? Because they're all different. And so we're going to have to choose a point. All right, now at this point, what is that instantaneous rate of change? Instantaneous rate of change. So because it's really hard if you have different rates of change on a curve. So let's get to it. So the gradient of gradient, now gradient is slope, which again is going to be our rate of change, of the tangent curve at A is the instantaneous rate of change of f of x at A. So what that means is if we drew in, and I'm just going to erase this first line. What a tangent curve is going to be at point P. This one says A. I tried to get same letters. I'm sorry, everybody. But at a certain point, whether it's point P or point A tangent line is a line that comes in, touches the curve, and then goes back out. So that's what they mean by tangent to the curve at A. Okay, this is the derivative. First, I put some notation. This is f prime of x, and I'll write that out for you. F prime of x, which means the derivative of x, and I'm going to get there in a second. Or we can write dy over dx, which is the derivative of y with respect to x. And so there's a few other ways of writing it. You may have seen it in another video that I showed you. But what does it all mean? So what do we mean? All right, so we know a couple things. We know that we're going to be talking about slope, which is the gradient. These are the same concept, which is going to be our instantaneous rate of change. So we're going to be having to look at a formula, probably the slope formula. So let's get to the example. Okay, so we have a curve. And we have this line, and what we're going to do is we're going to capture the gradient of this actual curve, but we're going to be using this line to do it. So we're going to be finding that slope of this line to capture the rate of change of this actual curve. And so we have 2 points. We have the original x, and then we have our x squared. So you want to think of this in terms as x1 and y1. Okay. And then we have x plus h. Well, now, where did I get my h from? My h is because I'm moving over in order to get to this point. So that's where my h came from. So we have x plus h, so I just added it there. So this is going to be x2. And we have our x plus h squared, because this was squared, and we're adding our h to it. So this is our y2. And you will have remembered way back in Algebra 1 or even 8th grade, or we learned about gradient. We probably definitely reviewed it in this course, which is slope, which is y2 minus y1 all divided by x2 minus x1. And we can say that this is the change in y, delta y, divided by the change in x, delta x. I'm wondering where that d came from. Delta y over delta x. So we're going to be using our slope formula, and we're going to be using our points, and we're going to be putting our points into the slope formula. And I need you to bear with me here because you are not going to be doing this entire process every time. I am going to show you the rules that the wonderful calculus mathematicians have developed over the years for us to use. But I do want to show you this one process because I want you to understand when we do our rules where it actually came from. So let's do it. So we're going to use our slope formula. I'm just going to do delta y over delta x. So we have delta y over delta x. So we're going to be taking our y2, which is going to be x plus h divided by 2, minus our y1, which was x squared, all divided by our x2, which is x plus h, minus our x1, which is x, right here. Okay, so we labeled our points and we put them in. Now let's simplify a few things. What I'm going to first simplify, and I'm just going to keep going, I'm just going to keep working like across and down. The first thing I'm going to simplify is this denominator. I'm going to do x plus h squared minus x squared. I can take these parentheses away, so I have x plus h minus x. There's no number to multiply, so I can just remove them. And we have a positive x and a negative x, so these two cross out, so my denominator is just my little lonely h. So this is going to equal, we have h on the bottom. Now that I simplified that, let's simplify the top. You cannot subtract an x squared yet because we actually have to multiply this out. So I'm going to do x plus h times x plus h minus x squared. And please remember, we have to use FOIL on this. We have to multiply this out entirely. Remember, the square is times itself. So I'm going to do x times x, which is x squared, x times h, which is xh, h times x, which is another xh, plus h squared, and then I'm not going to forget my minus x squared. Okay, and that's all divided by h. Let's keep going because I can combine a lot of things here. So we have a positive x squared and a negative x squared. I love this. You cross it out. This is one of the things that I absolutely love about algebra and about calculus is when we get to cross things out. All right, so we can cross those out. We have two of these. We have two x plus h's, so x plus h plus x plus h is 2x plus h. And then we have our h squared left. And we have our h on the bottom, on the denominator. Okay, so simplifying even further, in the numerator, I want you to notice that this term, 2xh, and this term, h squared, they both have an h in it. So what I can do is factor out, divide out that h. So if I divide out an h from 2x, if I take that h out, I have a 2x left. And if I take 1 out from h squared, I have 1 left. And the reason why I did that, and I'm hoping that you can see this, is because I get to cross out the h's. I can only cross out anything from numerator and denominator if it's linked by multiplication. So I can't do it here because we have this addition sign here. I can do it here because this h and 2x plus h, these are linked by multiplication. So I can cross out. And what we have left is delta y over delta x, which equals 2x plus h. And if you will notice, the highest exponent here is 1. This is an exponent of 1. When we have an exponent of 1, guess what we have? We have a linear equation. And this is representing the instantaneous rate of change of this curve. So, long process, it comes from our slope formula, and inputting the 2 points that form that line because we can't find that constant rate of change on a curve. So we chose those 2 points and we are able to come to our derivative, which is 2x plus h, which represents that instantaneous rate of change. And I want to write that somewhere, but I don't really have any room, so I'll write it over here. And you could represent this a couple ways, and that's what we're going to be doing on the next page. Now, again, we're not going to be going through this whole process every time. We're going to be learning about rules. So let's learn about those rules right now. The first rule is going to be, and so there is an easier way, which is called the process of differentiation. And so the first one is called the power rule. The power rule says if n is any real number, f of x equals x to the n, then f prime of x equals n to the n times x to the n minus 1. What the heck are we doing here? Okay, so let's figure it out. Let me write this out a little bit bigger. So if we start with f of x equals x to the n, what happens is if we take the derivative, if we differentiate it, we do f prime of x. That means that we're differentiating it from here to here. And so what's going to happen is this n is going to be multiplied by whatever number is in front. So n times 1 is 1n. So that's why the n comes down here. And then you're going to write your x. And then since you brought that down, you're going to have to take whatever number this is, you're going to have to subtract 1, minus a 1 out of it. And so that's how we get the power rule. So what does it look like with numbers? So here we have number 1. We want to do the derivative. So this is really a 1. We have f of x equals 1x squared. That's a 1 in front. So in order to take the derivative, what we're going to do is we're going to do 2 times 1, which is 2. Bring our x down, and then we have to do 2 minus 1. 2 minus 1 is 1. And so we can rewrite it, f of x equals 2x. So we turn that into a parabolic, into a linear, quadratic to a linear. And that is that's it. That's the power rule. That's how you use it. Let's do it again. Number 2. We want to differentiate, so f prime of x equals 11. We're going to multiply it by the number in front. 11 times 3 is 33. Then we have to subtract 1. X to the 11 minus 1 is 10, and you're done. Perfect. Let's look at some other examples. And I feel like I need to move my screen down, and I'm just going to refocus everybody. I feel like it's just not focused. These are really small, so I'm actually going to rewrite it for you. This is f of x equals 1 over x to the 4th. It looks a little bit bigger to me, but somehow they're fuzzy and small for you. So this was originally f of x equals 1 over x to the 4th. Here we have to do a little work. So we need to actually bring this up to the numerator. We can't have that in the denominator. I don't want to work with the exponent in the denominator. So what I'm just going to rewrite this is f of x equals, when you bring it up, the exponent actually becomes negative. So if you have a variable with an exponent in the denominator and you want to move it to the numerator, you put the negative in the exponent position. And now in order to take the derivative, f prime of x, what we're going to do is negative 4 times 1 is negative 4. X, and then negative 4, we have to subtract 1. Just be careful, it comes out as negative 5, because negative 4 minus 1 is negative 5. So a couple extra things to do. And number 4, same thing, and I didn't even put an f of x. So let me rewrite this for you as f of x equals 4. 4th root of x to the 5th. Now this is the root and this is the exponent, and in order to, I can't work with this root. So what I want to do is I want to change it so that this is a fraction, the exponent is a fraction. So we have x, and how we do that, it's always going to be the exponent 5 divided by the root 4. So if you want to remember that, it's always the exponent divided by the root. And that's how you remove that symbol, is making the exponent, and I should even write it a little bit smaller, into a fraction. So this is going to be 5 over 4. Okay, and so now we're going to do the same thing. We're going to multiply it by the number in front. So f prime of x equals 5/4 x, and then we're going to subtract 1. Minusing 1, if you want to do a little work up here, 5/4 minus 1, we need a common denominator, times 4 times 4, so minus 4 over 4, and that gives us 1/4. And so this is going to be 1/4, and that's it. That's it. You can leave it like that. If you do, I'm not sure if you have a professor or a teacher that wants you to put it back into the 4th root, you can. It would be 5/4 would be out here. I'm sorry, I'm squishing everything here. Your 5/4 would be here, and then it would be the 4th root of x. So that's how you would write it if you would needed to put it back into the root. The 5/4 stays outside though. That is the coefficient. Okay, number 6. Let me rewrite it for you. F of x equals 3 over x to the 12. Again, we have to get this into the numerator. So in order to do that, what we're going to do is we're going to rewrite it as 3x to the negative 12. Now we can take the derivative. F of x equals negative 12 times 3, negative 36x, and then we have to subtract 1, so that's minus 13. There we go. Now, we've just been dealing with one term. What happens if there's two terms, like f of x? We have 5, and then we have 3x squared. So this is 2 terms. Well, if you have 2 terms, do each one separately. I spelled that wrong. Separate. So the first one that we're going to take care of is 5. And so how I'm going to write this is actually when you have a number without a variable, there's no x here, it's done, it's gone. You multiply it by 0 and that's it. So you have if it's a constant, it gets dropped. It's out of there. So anything without an x term is out. So we did that one. Now let's do this one. 2 times 3 is 6x. 2 minus 1 is 1. So that's it. So any constant gets dropped. No x. Get it out of there. Okay. 2 more. And a little bit different. We have different letters, S and T. So we could write this as S prime. That's absolutely fine. We haven't used, there is, delta y over delta x. We haven't used that. I could have represented everything as delta y over delta x. So you're going to see in your calculus courses different ways of writing, hey, I'm taking the derivative. So if there's a different letter, you can just do S prime. We could do ds over dt. That's absolutely fine too. It's just the 2 variables, the y variable and then the x variable. So don't be intimidated if the letters change. We're doing the same exact process. Now, this one, you do have to do some upfront work. We cannot take the derivative when we have 2 parentheses and need to multiply it. We need to multiply it first. So this is going to be t times t, which is t squared, and then minus 2t, and then plus 1t, and then minus 2. I just used FOIL, and I'm going to simplify it, and this is actually not the derivative yet. Sorry for the erasing. I just don't want to confuse people. This is not the derivative. I'm just kind of multiplying this out in order to be able to take the derivative, so I'm kind of glad I made that little error. So let's combine these 2 terms. So t squared, combining these, we get minus t minus 2. Now I can take the derivative. I have 3 terms, 1, 2, 3. I need to do them separate. So the first one I'm doing is t squared. Okay, so let's move that down. So 2, remember this is a 1, we're multiplying here. Remember we multiply, 2 times 1 is 2. T to the 2 minus 1 is just 1. I'm not even going to write the little 1 there. Okay, next, so I'm doing this one, okay? So we can put our 1's in. This is really a 1t to the first power. Okay, so let's multiply. 1 times negative 1, negative 1, and then we are going to do to the 1 minus 1, and when that happens, when we have, and I'm trying to get the little, t to the 1 minus 1, what happens is this is t to the 0. Anything to the 0 power becomes 1. So if you have t to the first power, you subtract it, it becomes t to the 0. It's 1, and 1 times negative 1 is just 1. So we don't write a t there. It's out. Okay? What else is out? You got it. If we take the derivative of a constant, it's out as well. So that is your answer. That's the derivative. That's what you end up with. That's it. And it makes sense because we're going from a parabola to a line, from quadratic to linear. So there you have it. But you have to multiply out first. Multiply before you can take the derivative. Okay, and number 9, again, it's small, so let me just rewrite it. F of x equals 2x to the 4th minus 3x to the 3rd plus 1 all over x squared. And they're saying x can't be 0 because if it is, if 0 was here, we wouldn't have a function, so it can't be 0. There's your asymptote, right? That's what we're learning about. All right, do we have to do some work here as well? Yes. The first thing is that this has to be brought up to the numerator. And so I'm going to rewrite it as f of x equals 2x to the 4th, and I'm going to put parentheses around it because I want to keep it separate, minus, no, not minus, I'm sorry, times x to the negative 2. So when it comes up, it gets linked by multiplication. This 2 then becomes negative. And now you're right, we're going to have to multiply first. So we brought up our term, and now we need to multiply. So when we multiply, everybody, and I'm hoping I'm not losing you in this last one, when we multiply, and we're multiplying variables with exponents, we're adding the exponents. So to multiply, add exponents. And these are little things that you may not remember when learning about exponents and we're learning about multiplying quadratics that I'm reviewing, which is why this was going over 20 minutes. So this is really a 1 in front. Remember, we're multiplying. So f of x equals 2 times 1 is 2. X to the 4th times x to the negative 2. Let's add 4 plus negative 2 is x squared. That's out. Okay. Multiply here. Negative 3 times 1 is minus 3. X to the 3rd times x to the negative 2. 3 plus negative 2 is x to the 1st. And 1 times x to the negative 2 is a positive x to the negative 2. Now we're ready to take we're ready to differentiate. So let's write it. F prime of x equals, we have to do them separate. So 2 times 2 is 4. 2 minus 1 is x to the 1st. That's done. Okay, now let's do this one. 1 times negative 3 is negative 3. 1 minus 1 is 0, so that's out. Once it turns to 0, remember, we don't write the x. And this one here, negative 2 times, this is 1, is negative 2. X to the negative 2 minus 1 is negative 3. And so we are at f prime of x, which is the derivative, equals 4x minus 3 minus 2x to the negative 3rd power. And we're done. So I did start pretty simple with just using the power rule, but then what I did is I showed you some extra things that you may have to remember when you're differentiating, because it's not always going to be easy, and I'm hoping that these rules, remembering them and what to do first, will help you. This has been Dr. Mears and a little introduction, and my lights just went out. And I guess the universe is telling me you're done. All right, I hope this helped.